Hello everybody. Over the past year and a half, we and my colleagues from vascular department have been investigating is it possible and necessary to use 3D printing for our clinical work. Additive technologies are very useful, but I mean that the whole process takes place within the walls of the hospital without any outsource. And my little report about why we start thinking about it and what is the result. All of you, I guess, in your practice use such simple, fast voxel reconstructions. As you can see here, this is CT angio. It is available in all modern decom viewers. It can be done with a few mouse clicks and allows you to significantly improve your preoperative understanding of the anatomical situation. For example, in this case, according to 3D reconstruction, it was clear that the large anterior clinoid process would make clipping uncomfortable and its resection would be necessary. Creating such voxel model is a special case of segmentation, the simplest form of segmentation. And what is segmentation? Segmentation is the creation of volume corresponding to any significant anatomical structure. And this selected three-dimensional object, you can make a great variety of things using modern computer technologies. For example, the object has a defined volume, which means you know the exact volume of the tumor or hematoma or aneurysm, for example. You can put in 3D scene only those structures that are relevant to your surgery without unnecessary radiological noise. You can combine objects from studies of different modalities, bone from CT, for example, tumor from MRI, vessels from angio. You can use different ways how to view these scenes, for example, VR or virtual reality or augmented reality. And here are some examples. Here you can see usual voxel reconstruction of CT angio with giant internal carotid aneurysm. Optic nerves and chiasm were segmented from MRI and added here for more informative illustration. Here is the reconstruction of the cortex. It was made for searching of the small lesion. You can see that the reconstruction completely matched with intraoperation view. In our opinion, cortex reconstruction with veins for precise encephalotomy is more helpful than even neuronavigation, because navigation can have some issues due to registration or brain shoot, but anatomy is constant. You can segment any number of anatomical structures from different studies for your case, but visualization is not only thing. In 2021, I guess everyone knows that 3D objects can be printed, and 3D printing has become available and cheap. Many medical manufacturers have started to insist that 3D printer should be installed directly in the clinic. In this way, production would be as close to the patient as possible, thus making treatment faster and cheaper. Dentists were the first for sure. Now they can make many different things: temporary crowns, mouse guides, aligners, surgical templates, and many more. Traumatologists also start to use 3D printing. For traumatologists to surgical models, templates, spacers. We decided not to stand aside and to investigate this issue. So we have got several machines. We tried both printing technologies, FDM and SLA, and here are some of the uses we found. Special training models can be prototyped and printed. In this model, the bone path is made of dense polylactite and the brain is made of soft polyvinyl siloxane. This model is for training for creating of microanastomosis in lateral sulcus. We have made 15 such models for our course. Next one, model of neurovascular conflict, consists of two parts too. White path was SLA printed. Nerves and vessels were colored with acrylic paint. And very interesting thing is surgical models. I know that in many clinics before the operation, surgeon prints similar models for preparation. You can simply study them, you can try to cut it for planning reposition of fragments, or you can form a flap from soft titanium mesh according to the model and then sterilize it for implantation. Surgical guides are rarely used in neurosurgery, but it can be helpful, as in this case, to perform craniotomy without opening the large frontal sinus. As you can see, here there is enough space for dissection and clipping despite unusual approach. Surgical guides also can be used for making bone resection. Hyperostotic may be when after that the implantation of already prepared complex implant is scheduled. Or another interesting thing is for accurate spinal screw implantation. Cranioplasty after decompressive craniotomy is important part of the work of vascular department. Currently, it is possible to order customized printed titanium meshes, of course, but modifiable plastic implants still have many advantages and often used. Intraoperative creation of an implant using special molds is simple and widespread. Making of silicone molds for intraoperative creation of PMMA implants is absolutely possible within the walls of the clinic. We have studied the available modeling and printing methods, available materials, and at the moment we can make such form anytime. It takes a few hours to produce one, and it is possible to make CT, printing and surgery all in one day. I already mentioned about guided resection and some simultaneous reconstruction with prefabricated implants. Here you can see such case with one stage resection and closing. You can see that the roof was reconstructed in the most anatomically correct way. Here silicone molds allow to create even such complex implants like this one with the roof of the orbit. Devices prototyping is also a very interesting challenge. CAD programs became quite user-friendly and allow you to do some important things like these face shields that helped us when was the first wave of pandemic, or different plugs. Also, you can prototype medical devices, which will undoubtedly require the involvement of professionals, then licensing and other things later. Here is a device that we have already patented. A small navigation system for puncture of ventricles and hematomas, like tamale guide, but with more accuracy. Work on it is still on the way, but the initial results are encouraging. This is also our recent idea for creating individual craniometric rulers that can make it possible to do keyhole craniotomies faster with high accuracy and without using neural navigation. And that's all I wanted to say. The use of 3D technologies within the walls of the clinic is really possible. I believe in certified medical printers for neurosurgical needs, and if any of you have similar thoughts, let's think together. Thanks again, and goodbye.